Hello, my name is Dave Romrell at CommScope, and today I'll be sharing lessons learned in managing unplanned media transitions in Dash live streaming. Just a quick bit about me. I'm an engineering fellow in the Advanced Research Group at CommScope. I have 25 years in networking, mobile, cloud, and high-performance computing. For the past 12 years, I've been focused on service providers and developing highly scalable video and ad insertion systems. You may not know that CommScope has provided leadership in the TV advertising industry for over 25 years. Our footprint in serving local ads covers more than 70% of the US pay TV subscribers. With this deep understanding of cable and IP streaming and over the top, we continually look to contribute new solutions in scalable video ad insertion business. So today I'll be sharing lessons learned from our IP server-side ad insertion, which has been in deployment since 2015. Before we get into the unplanned media transitions, let me start with an overview of server-side ad insertion, quality, and the need for signaled events. The mission of server-side ad insertion is high-quality ad replacement at scale. Mature solutions must satisfy the full spectrum of streaming and operational needs, which often includes HLS and various modes of Dash. The output from server-side ad insertion must provide pristine playback experience across all the streams and device types. For the case of a live linear feed, the provider will have signals that mark the ad break period eligible for replacement. The quality of these transition points affects all the viewers of the channel, and I'll be focusing on how to handle the unplanned signals such as an early break return and the special case for transitions in Dash number mode. So server-side ad insertion produces personalized manifests or MPDs by removing the marked periods such as an ad break and replacing it with the ad content. Those periods can be forecasted, but a pristine transition will depend on the signaling for those media splice points. So the server-side ad insertion monitors the live feed from the packager for events that are often signaled by SCT35. So a pair of signals indicate the precise ad break start and the location for the ad break end, and sometimes that includes an unplanned early return. Similar cases happens for programs where there can be an indication of a start of a program that has restrictions like a restricted region or device type, and that program can be replaced with alternate content until the signal for the program end, which also can move with an early return or an overrun. And lastly, emergency alerts in some solutions also may have these unplanned transitions that are signaled by SCT18. So here are some diagrams to help us visualize an ideal ad break replacement on Dash. The diagram here on the left represents the packager output as it outputs each MPD update. And so each of these gray boxes is an MPD update, and they're numbered 8, 9, 10, 11. I'll explain that in a minute. When you look at the MPD at this point here as it's produced, it gives you a history of the published segments that were already provided at that time. And then the packager continues to update segments that are published until it reaches this point for the ad break start. At that point, I've colored the segments red because these are perhaps a national ad break, but they're eligible for replacement as you go through these segments here until you reach the end of the ad break, and then it returns back to the program content here. The diagram here on the right is the server-side ad insertion output, and it's basically reflecting the same as the packager. And so these are the same segments that are being reflected through the server-side ad insertion until it reaches the point of the ad break here. So as it reads this ad break over to here, it recognizes that it's going to replace the ad break segments with the ad segment shown in pink, and so that's the pink period here. And then it transitions to the ad 2, and it trickles out the ad 2 segments here in blue, and then it returns back to the program content here again in brown. The key up here on the right just gives us kind of the anatomy of the MPD. So at this point here, the depth here is called the time shift buffer depth, are the segments from the past. The point right here is a presentation delay where a client would start rendering in this past buffer and start downloading. And this point right here is called the MUP, or the minimum update period. And that's really significant for the discussion today. It says, when do I update this MPD next? And it sets the width of this. It also is what the number mode uses to anticipate how the segments will progress in time. And so over this minimum update period, it can continue to request the segment numbers that are anticipated from the packager. And so if we illustrate that over here, the download, the published segments from the packager here, the download rapidly tries to catch up to those segments, and then you'll notice it dips into these MUP periods and as it progresses. And so these are segments that were not actually in the MPD when it was published, but they were anticipated to be there if you continue progressing time forward. So that's a clean replacement case. Next, we're going to dive into the unplanned event and how those transitions happen. So the challenge of unplanned events are that they indicate immediate transitions to take place in switching media. The best example of this is a sports program, where there's a timeout on the field that causes the program to cut away to a commercial break. But then something can suddenly happen on the field that may be significant to the viewers, so they want to cut back to the sports program. So someone pushes a button, which essentially sends an immediate signal to abort the commercial and return early at that point back to the sports program. Implementing this is pretty straightforward for Dash timeline mode and HLS because the segments are being published with precise timing into the segment timeline, or in HLS, EXTMs. That timing allows the packager to indicate the variation like a short segment just before a splice point. And the other key part is that the client is discovering both the signal and the period of the new media at the transition, so it's clearly following the packager output. The dash in number mode is much more nuanced because the client is essentially given a script. The segment template tells the client how to download segments at a fixed duration, and then the client starts downloading at that rate and continues independent of the packager, which allows it to get in front of an unplanned signal. Underlying this is the fact that that MUP that I described is a forecast, so the client can continue forward beyond what has been published previously. So Dash has a neat trick. It's called the in-band event stream. And it allows you to include these signals inside the media segments. And so the client can, independent of the MPD, detect a signal and transition away. The challenge is, or the problem is, that once a client is playing replaced ad segments, they're no longer getting the live feed from the packager. And so you no longer can use in-band events because they're not received. So they're not helpful for this early return case. So let's briefly show some of the details of the MPD for the number mode. The top of the MPD has that minimum update period. In this case, it's PT 6 seconds, which says that the client should update this MPD that's being seen in 6 seconds. And then it has the period that contains the media, and in this case, that media is presented as a segment template. And on that media line, you see the $. That's a variable in the script that has a start number of 1, and then the duration of 180,000 ticks at the timescale presented here. And so the client can get the first one of these segments at 1, and then at 180,000 ticks later, it can go to 2, and again 3 and 4, and that can progress essentially indefinitely. And it appears to be somewhat endless from the perspective of the way the MPD is defined. So what stops the client from doing that forever is when the next MPD update comes with a new period that basically starts the client into some updated media or new segment template. And that's generally triggered by these signals that can be unplanned or planned. And the unplanned one can essentially preempt what was happening before, including having the segment that's smaller than the duration indicated. So detecting those unplanned events depends upon that MUP and having it short enough that the client is making requests to discover this new period. And it also, as I described here, the duration here seems like it's an estimate. It's actually called the fixed average duration, but it is an average. But the start time of that next period and something called the presentation time offset still indicates a very precise point in the media for these transitions. So even though the script that's given out is somewhat of an estimate, the actual splice point when it arrives is precise. Going back to that earlier example, let's visualize what happens with an unplanned early return. The packager starts here on the left with the same progression of segments going into the start of the ad break and continuing on. And you can think about that timeout on the field having a break that may go out for several minutes. The output from the server-side ad insertion is mirroring the same thing, and it does trickle out ad 1, and at the right point it also trickles out ad 2. The event on the field happens right here with this early return, and that's what causes a signal to come in with the splice immediate. And I purposely delayed this line just a little bit beyond when the update happened, so it wasn't known at the time update 6 was published. So what happens on the server-side ad insertion when there's a number mode and the client is playing is that the client still is projecting those segments, these blue segments, across the minimum update period. And so it actually got ahead of the point where that early return is. And so that's not yet an issue for the playback because the playback buffer hasn't reached that point yet, but it does cause a problem in that it's already had these segments downloaded and perhaps put into the buffer to be rendered. So the side effect here is really player dependent. A naive client might actually try to finish playing the blue and then play the brown, and essentially it double buffered through this, and that would create a real problem for live because it accumulates drift. Or perhaps the client might miss that case of the immediate return or do a reset and then start playing down here. Neither of those are ideal. The dash specification is actually clear, and it says that the start for this period that was here takes precedence, and so the client should backtrack to this point. And that still also has some side effects in the system. For example, the client downloaded these segments and now it's downloading these segments here. And so that creates some issues both to the CDN that gets extra requests as well as on the network where there's extra bandwidth and latency, and perhaps even to clients that have to adapt the bitrate. So that's not ideal. So our challenge is going to be, how do we handle an unplanned transition that avoids or prevents a naive client getting confused or these impacts to the system for this double download period? So we really want to avoid getting into this condition to begin with. So on the next slide, we'll talk about solutions. Let me outline a couple guidelines and some options for handling the unplanned transitions. The first guideline is the packager should publish the next period start as soon as it's known. The client will then know that that prior number template is done and will stop before it goes into the next MUP. Dash calls these an early available period, and they can be published without media in them, which is really interesting for queues that come several seconds in advance because you can indicate the transition, and then as the queue arrives, you can fill it with media. The challenge is that unplanned transitions are immediate, and therefore there's no lead time before them, but it's still useful to indicate the start even before that first segment is known. The second one I've already indicated previously, and that's a server-side ad insertion should be careful to avoid publishing the ad periods in front of the packager. So you'll note that I was trickling out the ad periods like ad period 2 only at the point where the entertainment content or the ad break content reached that same point. And that appears better to the client as well because the live feed has a constant progression. Then let's get into these two options. So the first option is this setting of the UTC timing element. This is something that's in the dash spec and allows you to manage the client's clock value, which is what it uses to calculate those downloads. So essentially, the principle is to hold the client back to the clock value of where the packager has been at as it's updating the MPDs. And it's very similar to the segment timeline, or HLS, which the client only can progress as it sees the segments. In this case, it's as it sees the clock of the packager move forward. However, some clients don't honor the UTC timing value. They use their own clock for pacing. You might sync it, but it doesn't actually allow you to manage that clock. The last option that I'll review is the availability start time. And this is a reference that the client uses to calculate where that download point is. And so by shifting that value, you can shift the client's download point back and keep it from getting into that period where the media is unknown. And so I'll show that in the next slide. Lastly, I want to reiterate that it's really important that the client is graceful and follows the dash standards, so it precisely renders the period transitions as expected. So let's illustrate these two options. The one on the left is the UTC timing option, where the MPD gives a clock to the client and essentially only allows it to catch up to where the packager clock is. And so each of these updates only gets to that point, and it can't project any further beyond that. And that's similar to a segment timeline, or HLS, when a packager puts out new segments. It basically can go up to that point. The one on the right here is an AST shift. And the AST shift basically takes the point of reference used by the client's clock and shifts it back. And so the download point here is staying behind because we've shifted the reference to be used. In both these cases, as we come up to this early return or unknown or unplanned event, the client doesn't get ahead of itself. Therefore, you don't confuse those naive clients, and you avoid the bandwidth issue of a double download at these locations. So they're both acceptable solutions. So a few concluding thoughts. The first one is I want to observe that the dash standard provides a lot of flexibility in implementations and adapting to these various conditions. The other one I want to reiterate is that the in-band event stream does not help clients that are playing alternate media. Again, they can't receive the live signal when they're playing something that was produced elsewhere. The number mode templates have some very popular advantages, but there's nuanced edge cases for where the client is playing that can be preempted by an unplanned event. And the UTC timing, the AST shift, are both methods that you can still adjust those clients and still provide a pristine client experience that avoids that race condition that can occur if it gets ahead of it. Lastly, I want to talk on low latency. There is a real tension between these real-time events or signals that you may need to take action on and the client behavior and request rate in order to discover and follow those events. And so that's a point that's going to end up, as we squeeze the times, becoming more significant as far as how we respond or support real-time events. With that said, I welcome questions and will respond to them as I'm able. And if you have any needs with server-side ad insertion and real-time events, it's an area where we've developed quite a bit of experience and have found success in production environments. And thank you very much.